Base isolation, also known as seismic base isolation or base isolation system, is one of the most popular means of protecting a structure against earthquake forces. It is a collection of structural elements which should substantially decouple a superstructure from its substructure resting on a shaking ground, thus protecting a building or non-building structure's integrity. Base isolation is one of the most powerful tools of earthquake engineering pertaining to the passive structural vibration control technologies. It is meant to enable a building or non-building structure to survive a potentially devastating seismic impact through a proper initial design or subsequent modifications. In some cases, application of base isolation can raise both a structure's seismic performance and its seismic sustainability considerably. Contrary to popular belief, base isolation does not make a building earthquake-proof. Base isolation system consists of isolation units with or without isolation components, where 1. Isolation units are the basic elements of a base isolation system which are intended to provide the aforementioned decoupling effect to a building or non-building structure. 2. Isolation components are the connections between isolation units and their parts having no decoupling effect of their own. Isolation units could consist of shear or sliding units. The first evidence of architects using the principle of base isolation for earthquake protection was discovered in Pasargadae, a city in ancient Persia, now Iran. It goes back to 6th century BC. It works by having a wide and deep stone and mortar foundation, smoothed at the top, upon which a second foundation is built of wide, smoothed stones which are linked together, forming a plate that slides back and forth over the lower foundation in case of an earthquake, leaving the structure intact. This technology can be used for both new structural design and seismic retrofit. In process of seismic retrofit, some of the most prominent U.S. monuments, for example Pasadena City Hall, San Francisco City Hall, Salt Lake City and County Building or Louisiana City Hall were mounted on base isolation systems. It required creating rigidity diaphragms and moats around the buildings, as well as making provisions against overturning and P-delta effect. Base isolation is also used on a smaller scale, sometimes down to a single room in a building. Isolated raised floor systems are used to safeguard essential equipment against earthquakes. The technique has been incorporated to protect statues and other works of art. See, for instance, Rodin's Gates of Hell at the National Museum of Western Art in Tokyo's Ueno Park.